Hello everyone and welcome. आज हम इस source material को detail में समझेंगे. We are taking a totally fascinating journey straight into the heart of artificial intelligence. We're going to unpack, layer by layer, exactly how machines think, how they learn from their mistakes, and how they're being programmed to make decisions that rival, and sometimes even completely surpass what we humans can do. If you've ever wondered what's really going on inside that digital brain of theirs, well, you are in the exact right place.
Okay, let's dive into this. Here is our roadmap for today. We're looking at the AI universe, then data, the new fuel, rule versus learning models, a deep dive into machine learning, and finally we'll go inside neural networks. Let's get to it.
Section 1. The AI Universe, the Hierarchy of AI.
Think of AI kind of like a set of Russian dolls. Artificial intelligence is that outermost overarching universe, the whole grand concept of creating machines with human-like thinking abilities, right? You open that doll up, and inside, you find machine learning, or ML. This is a narrower subset where machines use statistical algorithms to actually learn from data so they improve their performance over time without us explicitly programming them for every single scenario. And then, you open that doll, and you find the deepest, absolute, most advanced subset, deep learning, or DL, which relies on these incredibly complex, multi-layered structures called artificial neural networks to solve highly sophisticated problems.
This idea brilliantly illustrates the practical difference between those two inner dolls. See, with machine learning, we might give the system a relatively basic task, like sorting photos of apples from oranges based on obvious things like color and shape. But deep learning, it goes way, way further. It doesn't need us to spoon-feed it. If you feed it an image, DL can automatically extract complex layers totally on its own. First, it might detect primitive edges, then colors like blue. In the next layer, it picks up facial features like eyes and a mouth. Finally, it recognizes patterns, maybe circles and 8 tentacles, and it combines all of that to independently conclude, hey, this is a cute blue octopus. It's wild.
Section 2. Data, the new fuel. Let's talk about feeding the machines.
The legendary Ratan Tata famously said, "Data is the new fuel." And honestly, it is incredibly accurate. Without data, an AI model is literally like a high-end sports car with no petrol. It's just sitting there, going nowhere. Data is the machine's absolute fundamental food. Everything it learns, every single prediction it makes, stems entirely from the massive amounts of data we feed it to help it recognize those statistical patterns.
Now, when we feed a machine this data, it's usually highly organized. In pretty much any data set, we have something called features. Just think of these as the columns of a table. If we're looking at fruits, the specific color or the price are the features that the algorithm weighs mathematically to make its future predictions. It's basically the raw collection of facts that the machine breaks down into pure numbers.
So the really crucial point here is exactly how we present this data to the machine. We basically have two main ways. First up is labeled data. This is when we give the machine the answers right up front. We show it an image and explicitly attach a tag that says dog. The machine learns the mapping between that image and the label. Simple enough, right? Then we have unlabeled data. This is where we just hand the machine a massive pile of images with zero descriptions and essentially force it to figure out the structural similarities and hidden patterns entirely on its own.
Now, how do we actually know if it learned anything? Well, we split our data. Step 1 is the training data. To put it in a totally relatable way, training data is like the teacher standing in front of the class, explaining the whole Ram Kata. It's the long, detailed lecture. Step 2 is the testing data. This is the sudden surprise test. We throw totally new, unseen data at the machine to see if its thick brain actually grasped the concepts and underlying logic, or if it was just blindly memorizing the training examples to trick us.
Section 3. Rule versus learning models. Fundamental AI rules.
There are two main paths for AI modeling. On one side, we have rule-based models. Think of a super rigid customer service chatbot for a clothing brand. A developer writes strict logic. If the user types track order, show tracking. But if you ask it something even slightly unexpected, it completely fails and just tells you to call customer service. It's entirely static. Contrast that with learning-based models. A perfect example is your Gmail or Apple Mail spam filter. You don't have to sit there and code every single spam word. It constantly adapts, finding hidden patterns like weird links or clustered emails, dynamically learning the mechanics of spam to keep your inbox nice and clean.
Section 4. Machine Learning, a deep dive.
Let's really break down supervised learning. Again, this is the type that uses that labeled data we just talked about. It has two main subtypes. First, classification. This is all about putting things into rigid categories. Is the weather hot or cold? Is this email spam or not spam? The algorithm draws strict decision boundaries. The second subtype is regression. Now, this doesn't use rigid buckets. Instead, it predicts continuous numerical values. Because things like financial charts or temperatures have infinite possible decimal points, regression algorithms track these continuous curves to predict things like salary growth or stock market trends.
Now let's look at unsupervised learning, which uses unlabeled data. Here, the machine has to find its own way. The first subtype is clustering. It looks at thousands of images and naturally groups similar items into clusters based on visual distance, like separating dogs, cats, and monkeys, or grouping your favorite songs by their acoustic tempo. The second one is association. This is all about finding hidden relations in huge databases. Supermarkets actually use this heavily. If a customer buys bread, what is the mathematical probability they'll associate it with buying butter? Oh, and there's one more branch worth mentioning called reinforcement learning, which simply put is the machine learning via pure trial and error, basically getting digital rewards for correct actions.
Section 5. Inside Neural Networks. Inside the Brain.
Deep learning relies on artificial neural networks, or ANNs, and these are deeply inspired by the biological structure of the human brain. Instead of biological neurons, they utilize digital processing nodes. ANNs are essentially the foundational brains of modern, highly advanced machines. They auto-extract features to power vast, incredibly complex applications in everything from stock market prediction and healthcare diagnostics to weather forecasting and even advanced defense systems.
So how does an ANN actually process a thought? It happens in 3 distinct steps. Step 1 is the input layer, which takes in the raw data, say a picture of a dog. Step 2 is the hidden layer. This is where the absolute magic happens. It uses complex math, weights, biases, and activation functions to process that data. Step 3 is the output layer, delivering the final prediction. Now, what happens if the machine messes up and calls the dog a cat? The hidden layer actually fixes its errors via a process called backpropagation. Think of it kind of like going to the gym. You start with terrible form, but after making a mistake, you physically adjust the weights on your bar. The neural network does the exact same thing, mathematically tweaking the weights or the importance of different data points across thousands of connections until it finally learns the perfect prediction.
Now, what's really interesting here is a specific type of neural network called a CNN, or convolutional neural network. These specialize entirely in processing image pixels through localized grid filtering. And honestly, CNNs are incredibly powerful. They're the exact tech powering the Face ID in your pocket. They run Google Lens for object detection. They can even extract text from a photo to catch someone cheating on an exam. And they flawlessly recognize handwritten digits by mapping the curves of the ink, no matter how messy your handwriting actually is.
So we've unpacked this whole ecosystem, from basic statistical features all the way up to convolutional neural networks that see the world just like we do. Which really leaves us with this final thrilling thought. If these machines are constantly learning from our daily data, adjusting their mathematical weights and mimicking the human brain to near absolute perfection, what will they learn to do next? Thank you so much for joining me on this deep dive into AI modeling. Keep learning, keep questioning, and I will see you next time.